Hey guys, welcome back for more statistics. Today we're going to continue our look at the confidence interval for proportion, and we're going to play catch. So what proportion of the Earth is covered by water? We will investigate this question by taking a random sample of locations on the globe. So usually what would happen if we were in class is I have an inflatable globe and we would kind of throw it around class and people would randomly catch the ball, and wherever their right thumb landed, if it was on land, they would report land, and if it was on ocean, they would reply ocean. And this does a pretty good job of kind of randomly selecting, and it gives us a little bit of fun. So normally we would play catch in class. Of course, I'm not going to play catch with you over the internet. I wish I could, but what do you do? So the first part here is, how many locations did the class sample? Well, I'm going back a few years to the first time I did this in class, and in that class we had about 27 students in class, or 27 students who played the game. We had one student who was keeping tally, and every student had to touch the globe twice. So we sampled 54 locations. And of those 54 locations, 32 of those locations were the thumb landing on water. Calculate the proportion of locations in the sample that were water. Well, that's pretty easy. That's 32 divided by 54. And 32 divided by 54 is 0.5926. Now, the next part here is going to be our formal plan for constructing a 95% confidence interval, or any interval. It's a four-part plan, so it's usually called the four-part plan. And the four parts are state, plan, do, and conclude. This is going to be the same for most of the routines that we do here in second semester statistics. So let's start with state. Well, what is the parameter? So we need to state that we're looking at the proportion of the Earth covered by water. We also need to state the confidence level. Confidence level is usually pretty easily found. It's 95% in this case. And that's it for state. We just need those two things, and we're going to do those two things consistently every time we do a confidence interval. What is the parameter? What is the confidence level? The second part of the four-part plan is plan. And plan says that we're going to identify the appropriate inference method and check conditions. So the name of the procedure, and you're always going to name the procedure. Start off by saying how many samples you're going to take, and the answer for that's usually either one sample or two sample. In this case, it's pretty obvious we're only taking one sample because that's all we've learned. So this is a one sample. And then the next thing we're going to state is which of the statistical curves are we going to use, and we only really know the z-curve right now, so this is going to be a z interval. Whenever we're doing proportions, it's always going to be a z interval. And then we're going to write for a proportion because we're finding the z interval for a proportion. Well, that kind of makes sense. The next part here is to check the conditions, and remember there are three conditions that we need to check. The first one is random. So we need to say that the locations were chosen at random. The next one is a 10% condition. This one should be kind of obvious, but 54 is less than 10% of all locations on the Earth's surface. The next one is normal condition, and the normal condition is met because of large counts. We're going to go to those formulas. And for this, NP is always the number of successes. So we know exactly how many times we sampled water, and that was 32 times. So we don't actually have to do any of the multiplication here. We're just going to say 32. And then finally, N 1 minus p is 22, the number of times we didn't hit water, and that of course is also greater than or equal to 10. The do part here is if the conditions are met, perform the calculations. You notice there are 4 things in the do part. First is the general formula for any confidence interval, and that's always going to be the same. That's the point estimate plus or minus the margin of error. Next, you're going to write down the specific formula for this confidence interval, and the specific formula is P equals P hat plus or minus Z star, P hat 1 minus P hat over N, all of that in the square root. Then you're going to plug in the numbers. Here we go with the numbers substituted, 0.5926 plus or minus 1.9, and that should be 1.96. 1.96 multiplied by the square root of 0.5926 multiplied by 0.4074, the whole thing over 54, and then we're just going to compute our answer. That gets us 0.5926 plus or minus 0.1311. Lastly, we're going to conclude by interpreting our interval in context. Here's our sentence frame. Let's go blank by blank and substitute what we know. We are 95% confident that the interval from 0.4615 to 0.7237 captures the true proportion of the Earth's surface covered by water. Let's read this one more time to adjust for readability. We are 95% confident that the interval from 0.46 to 0.72 captures the true proportion of the Earth's surface covered by water. Sounds pretty good to me. And there you have it, the 4-step plan for a confidence interval. Not so bad, right? After everything that we've done already, having these 4 steps is actually kind of a relief because you know exactly what you need to do for all of these problems. So let's go over our important ideas, and our first learning target is that 4-step process. Again, 4 steps. First, you want to state the parameter and the confidence level. And then you're going to plan by giving the name of the procedure. So remember, that's the number of samples, the statistical curve, and then the parameter. And what are the conditions? There's always going to be those 3 conditions: random, 10% rule, and normal condition. Next, you're going to do the do part. Do has 4 things. You're going to write the general formula, which is always point estimate plus or minus a margin of error. The specific formula, and we only know 1 right now. Then you're going to substitute the numbers, and finally you're going to calculate the final interval. You don't actually have to show any of the math behind what's going on. So you can just do it all in your calculator. As long as you write those 4 things in the do part, you're good. Lastly, you're going to use the sentence frame, and it's the same sentence frame for every confidence interval. You're going to use that sentence frame to write a conclusion. Sometimes you're going to be asked to state the sample size for a given margin of error. And in that case, you're going to use a margin of error formula, which is the critical value multiplied by standard error. And you're going to use either the solver in your calculator, or you're going to use algebra to solve for n. Always round up whatever you get from the solver or from your algebra. And if p hat happened to be unknown, you're going to use 0.5 in all cases. So if they don't give you a p hat, again, use 0.5 to calculate the margin of error. It's called the conservative approach because it gives you the maximum sample size needed to create that margin of error. If you had a better estimate of p hat, then you would have necessarily, it would be a smaller sample size. But 0.5 makes the biggest sample size needed for the margin of error, regardless of the actual value of p hat. So do you got all that? Did we go over it well? I admit, probably a little bit quick, but I have a feeling that we'll get to do it a little bit slower here on our next Check Your Understanding. So we've got a company who's received complaints at its customer service. What is new? The managers intend to hire a consultant to carry out a survey of the customers. Before contacting the consultant, the company president wants some idea of the sample size that she will be required to pay for. One value of interest is the proportion of customers who are satisfied with customer service. She decides that she wants to estimate within 0.3 percentage points at a 95% confidence level. So the first thing to be aware of is when it says within 3 percentage points, that's code word for margin of error is 0.03, 3 percentage points. Using a conservative estimate, how large of a sample is needed? To answer this question, we're going to just write out our margin of error formula first. Then you're going to substitute your numbers. Notice Z star is 1.96 because we solved for a bunch of those, and the 95% confidence interval is used so often that people just tend to memorize that number. So the Z star for a 95% confidence interval for Z is 1.96. Also, we didn't have an estimate for p hat, so we're using the conservative approach and using 0.5. And then we're going to make that equal to the desired margin of error, 0.03. Now remember, this is stats, so it's not necessary for you to show any algebra here. So if you don't want to do the algebra here, you can go ahead and go to your solver right now. So here we are in our calculator. We're going to push math, and then we're going to scroll all the way to the bottom until we got to solver, and we're going to push enter. I have a formula in here from calculus, so I'm going to clear it off. And we're going to do the left side of the equation, which is the margin of error. And I'm going to put the letter M here for margin of error. And then the right side of the equation, I'm going to clear that. And I'm going to put Z for Z star multiplied by the square root. And then I'm going to put a fraction because that's what I do. This is going to be P. So I'm going to literally put a P here. And then parenthesis 1 minus P. Close up parenthesis over N. Okay, I find it's much better, instead of putting the numbers in there, if you put the variables in there, you're probably going to make less errors. And it doesn't really matter because, as you see, when we go to the next screen by pushing down, we have the opportunity to input all of those numbers. So we're going to input what we want the margin of error to be. So I'll put 0.03. I know what Z is. Z is 1.96. I know P is 0.5. That's actually P hat. But I don't know what N is. So here, to solve, I need to start off by putting a guess for N. You don't have to make that great of a guess. I'm going to put 100. I think you'll start to run into problems if your N is a negative value. But as long as you have something reasonable, 100 is a good place to start, for example. Then you're ready to go. The last step for using the solver is I'm going to push alpha and then enter. So alpha enter will give me the correct value, which is 1067.111. Now remember, we want to round that up, so the answer we want is 1068. And that completes that first part of the question. Question 2 says, in a company's prior year survey, 80% of the customers surveyed said they were satisfied. So using this as a guess for P hat, find the sample size needed for a margin of error of at least zero, or at most 0.3 with a 95% confidence. How does that compare with the sample size from question 1? I'm already going to tell you the sample size is going to be smaller because 0.05 was our conservative approach. It's the biggest sample that we would need to create a margin of error of 0.03. But that's okay. We're going to go pretty much do the exact same routine. The only thing that changes in our equation, and yes, you need to write the entire equation all over again, the entire thing. The only thing that's going to change is p hat and 1 minus p hat. So that's nice. Let's go to the calculator. Again, we're going to change our value of p hat to 0.8. And then 1067 is a pretty good guess because that was one of our answers. And I'm going to push alpha enter now because everything else is the same. And that got me 682.95, round up, so 683. So 683, and of course, like we said before, that is a smaller sample size than what we got in question 1. What if the president demands a 99% confidence interval instead of a 95% confidence interval? Would this require a smaller or a larger sample size, assuming everything else remains the same? So think about what's going to happen here. If we use a 99% confidence interval, the interval itself is going to increase. So more confident means bigger and more plausible values, which means bigger interval, meaning if we kept everything the same and only increased the confidence level, then the interval would have to get bigger. If we want to maintain the same the same margin of error of 0.03, we need a way to make the interval smaller. And we can make the interval smaller again, back to 0.03, by making the sample size bigger. So more confident means a bigger margin of error. So we're going to have a margin of error that's bigger than 0.03. And then to shrink it back down to 0.03, we need to increase the sample size. We can see this in action if we go to the solver and we only change z, which is for a 99% confidence interval 2.576. We're going to notice that that's going to change our value of the margin of error. So we're going to change the margin of error to 0.039. But if I want to keep it at 0.03, then now I'm going to look at what happens to the sample size. So it was at 682, and now it's going to go back to 1179. So it's got to increase quite a bit, actually. So changing the confidence level will increase the margin of error. To decrease that margin of error back down to 0.03, we're going to have to increase the sample size. So that's it, everyone, for our stats today. Hopefully, we've got some good things here. The 4-step plan is really important for you. We are going to use that all the way to the end of the semester, pretty much. So like I said in all the previous ones, learn it now, get good at it now, get a lot of practice now, and then, the rest of the semester will be a breeze. So that said, I'll see you guys next time. Have a good day.